2, 1.
Hi, my name is Peter Jackson. I'm here to tell you how to maximise your performance in the Chemistry Leaving Cert exam. The little picture on the right is my revision book for chemistry, so I just put that in there to let you know that I am well versed in chemistry. The paper layout, the first question is always a titration, the second is organic practical, the third is other practicals that are not covered in questions 1 and 2. Question 4 are the short questions on all the topics in Leaving Cert. Question 5, atomic structure, periodic table and bonding. Question 6, fuels, organic chemistry, the alkanes, the alkenes and alkynes. And at the end of it there's a thermochemistry question usually. Questions 7, 8 and 9, the order is not precise here, but there will be an organic theory question, and I will give you a flowchart and mechanisms to learn. Le Chatelier and equilibrium usually appears here, and environmental chemistry, which essentially is acids, bases, pH and water. Question 10 you do 2 parts out of 3, and question 11 you do 2 parts out of 4. Each question is worth 50 marks. One of the most important things to learn in chemistry are definitions. It's the same in any science subject. A large proportion of the marks are going to come directly from definitions. So in chemistry it's about 10 to 15%, sometimes more, rarely less. There are just over 100 questions that have ever been asked. So I'll give a link on the site where you can look at these definitions, and you should learn them. They're well worth it. Right? Almost all questions have at least one definition, and the word to be defined is usually in italics. These get marks directly just by knowing the definition, but they also help you to understand the question if you know what the technical terms mean, and it makes the topic easier to learn. So the first thing I always say is learn the definitions that go with the topic. And so definitions are worth a lot more than 10 or 15% in reality. So let's look at the questions one by one. Question 1, titration. There are 3 parts to this question, not necessarily A, B, C, but it can be broken into 3 different parts. How to use the apparatus properly, the indicator you use, the colour changes, and any special conditions involved when you add the indicator, whether it has to be acidified and so on. Question 3, or the third part of the question, is worth about 1/3 of the marks, and that is the calculation. So if you're not very good at calculations, you can still pick up an awful lot of marks from 1 and 2. In the calculations you will be asked to calculate the molarity, and then change that to concentration in grams per litre, and possibly concentration in parts per million, which is milligrams per litre, or perhaps percentage weight per volume. Question 2 deals with the organic experiments. Very often more than one topic is covered in this question. Now it used to be just one topic, but now they might put in ethene and ethine together in the question. Sometimes a percentage yield calculation is included, so make sure you know how to do those. Question 3 deals with the other experiments on the course. These are tests for anions and cations, the effect of concentration on reaction rate, the effect of temperature on reaction rate, and the production of oxygen from hydrogen peroxide with manganese dioxide catalyst. 2, 3 and 4 will usually involve drawing a graph. There's also relative molecular mass of a volatile liquid, recrystallization of benzoic acid and melting point determination for benzoic acid. This can also come up in the organic practical as well. The percentage of hypochlorite in bleach or in a swimming pool, and heats of reaction. That's where you react hydrochloric acid with sodium hydroxide and have to work out the heat of the reaction. Drawing graphs, very, very important. Many, many marks are thrown away needlessly in drawing graphs. So the points you need to remember are: 1. Use graph paper. There is graph paper in the answer booklet, so use that. Don't forget and put the question number in the small box at the top left hand corner, and when you in your question you can say see page whatever it is where the graph is. You must label each axis with 3 things: what it is measuring, the scale, and the units used to measure it. People throw away marks by missing out one of those. Make the graph as large as possible. The bigger the graph, the more accurate it will be, and the more accurate any calculations you get or use the graph to get will be. Mark your points carefully. Draw the line of best fit, either a curve, a smooth curve, or a straight line. Do not extrapolate unless it is justified. That would be in the temperature effect on rate. It doesn't start at 0, whereas concentration does start at 0, 0. Question 4, the short questions. It's the only question where you can get parts of it wrong and still get full marks. The questions are from anywhere on the course. You're asked to answer 8 out of 11. Each part gets 6 marks, and then 2 bonus marks are awarded. It's the only question where you can get parts wrong and score full marks. I've said that twice because it's very important to realise that. You should attempt all parts of all questions and you will be given the best possible combination of marks. And practice this by doing past paper questions, and that will be available to you in a document called Topic by Topic. Topics that appear regularly in this question are famous scientists and their contribution, definitions, electrons, protons or neutrons in an atom or in an ion, SPD configurations of atoms or ions. With the ions that's only up to 20, atomic number 20 that is, flame test colours, conjugate acid-base pairs, identifying the conjugate acid-base pairs, identifying the acid and the base, empirical formula from percentage composition, and mole calculations. There are many others, but practice doing these questions is the way you can easily learn all the answers. Question 6 is a combined question which deals with fuels and thermochemistry. Again, there are always definitions in this question. Crude petroleum and fractional distillation is covered here. Other fuels like hydrogen and biodiesel are covered here. Octane number and factors that affect it. Isomers, catalytic converters and how they work and what they're used for. Heat of formation and combustion equations. Hess's law calculation. This comes at the end of the question. This is a thermochemistry part. Nearly always a Hess's law calculation. Just occasionally the heat of reaction experiment. Question 7, I'm saying that's going to be organic theory, but it may be question 8 or even question 9, but usually 7 or 8. It's based on the organic flowchart. Again, I'll make that available to you. It deals with the type of reaction, the reactants involved, and the conditions. And the flowchart summarises all the different types of reactions, the reactions, and the conditions required. It usually includes a reaction mechanism, and one of the following pretty much always comes up in the exam. An alkane, that's methane or ethane, only methane or ethane with chlorine. This is a free radical substitution and you need to know the proof of the mechanisms. The second one is ethene with either chlorine, bromine or hydrogen chloride. These are ionic addition reactions, and again you need to know the mechanism, be able to draw it and give the proof of the mechanism. In fact, give 2 proofs at least of the mechanism. And finally, polymerization of ethene or propane This is called addition polymerization. It's a very, very short topic and it only comes up occasionally. Calculations. A lot of care needs to be taken here. There are certain rules to follow to ensure that you minimise any loss of marks, and you'll see what I mean by that in a second. Make sure that you know how to do the following on your calculator. Change a number to a negative log and a negative log back to a number. Work out square roots, exponentials. Whenever you use a molecular mass in a calculation, always show in a little box somewhere on the page how you worked it out. For example, CaCO3 equals 40 for the calcium, 12 for the carbon, and 16 times 3 for the oxygen. That equals 100. If you do that and you get 99 and use 99, then you will lose 1 mark. But if you just do it in your head and get 99 and use 99, you will lose 3 marks. So if you get 99 and used it in a calculation, you would lose 1 mark if you had shown the calculation, but you would lose 3 marks if you didn't show your calculation. And that's every single calculation on the paper. Your answers. How accurate should your answers be? Well, the best I can figure it out to be is give your answers to either 2 significant figures or 2 places of decimals, whichever is the most accurate. So if you have 2.64, don't give it as 2.6. 2.64 is 2 places of decimals and is more accurate than 2.6. Or the other way, 0.0056, not 0.06. 56 are 2 significant figures. Incorrect rounding off will cost you 1 mark, and that's in every calculation. About 30 to 40% of the marks in the paper come from calculations, more likely to be closer to 40, so work in your calculations. Practice, practice, practice your calculations. Question 8 deals, and it may be 9 and it may be 7, deals with environmental chemistry, water, acids and bases, and pH calculation. Water treatment and sewage treatment, not as common as it used to be as a question, but it still can come up, and it can even come up 2 years in a row. Don't assume because it came up last year, it won't come up this year. Hardness and a calculation and ion exchange are frequent topics. pH calculations, nowadays you're more frequently given the pH and asked to work out the concentration rather than given the concentration and working out the pH. And it's often the pH of a weak acid. Question 9, again it can be 7, it can be 8. This deals with equilibrium calculations and Le Chatelier. Again, definitions will come up here. The effect of changing the conditions on the reaction at equilibrium. The equilibrium constant, you'll always be asked to work that out, and you'll get usually 6 marks for it, occasionally 7. And then nowadays the questions tend to give you Kc and ask you to work out the concentrations. You may have to use the quadratic equation, but check if you can square root both sides. That makes it much easier. You don't have to use the quadratic equation. And remember that N2 plus 3H2 goes to 2NH3. When you're working out the amounts, N goes down by X, H goes down by 3X, and NH3 goes up by 2X. The coefficient in front of the formula tells you what you either take off or put on. On the left it's always going to be negative, on the right it's always going to be positive. Questions 10 and 11 are a mixed bag, they can come from anywhere. Right? In question 10 you do 2 out of 3, in question 11 you do 3 out of 4. Each part is worth 25 marks. This gives you extra choice. Topics include stoichiometry calculations, radioactivity, very small amount to learn for 25 marks, electronegativity is coming up here rather than in question 5. Energy levels can come up here too, as well as in question 5. Atomic structure, again, a lot of it comes up here again as extra question. And 11D deals with the options, either option A or option B, depending on what you've done. I hope you found that useful. Thank you very much.